Senior High School General Mathematics Core Subject. Rational Functions. Learning Goals. At the end of the lesson, the student is able to represent real-life situations using rational functions. Review. Polynomial functions. Definition. A polynomial function p of degree n is a function that can be written in the form of p of x equals a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus and so on plus a sub 1 x plus a sub 0, where a sub 0, a sub 1, and so on up to a sub n are elements of the real numbers. Also, a sub n should not be equal to 0. That means n is a positive integer. Each summand is a term of the polynomial function. The constants a sub 0, a sub 1, a sub 2 up to a sub n are the coefficients. The leading coefficient is a sub n. The leading term is a sub n x raised to n, and the constant term is a sub 0. Representing real-life situations using rational functions. Definition. A rational function is a function of the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions, and q of x is not the zero function, i.e. q of x is not equal to 0. The domain of f of x is all values of x, where q of x is not equal to 0. Real-world relationships can be modeled using rational functions. Consider the following examples. The local barangay received a budget of 100,000 pesos to provide medical checkups for the children in the barangay. The amount is said to be allotted equally among all the children in the barangay. Write an equation representing the relationship of the allotted amount per child, y variable, versus the total number of children, x variable. Fill in the table below with the different allotment amounts for different values for the number of children. Solution. Since the idea is to distribute the given amount to the number of children x equally, therefore the working equation should be y equals 100,000 over x. Depending on the number of children, the amount to be received by each child should be, say there are 10 children, therefore 100,000 divided by 10 gives us 10,000 per child. If there are 20 children, therefore each child should receive 5,000 pesos, for 50 children, 2,000 pesos, and so on. Let's say a philanthropist wants to supplement the budget allotted for each child by providing an additional 750 pesos for each child in the barangay. If g of x represents this new amount allotted for each child, construct a function representing this relationship. Fill up the table below with the new allotment under this scenario. Solution. Previously, the allotment for each child is represented by 100,000 divided by x, which is the number of children. Now, since it was described in the problem that each child will receive an additional 750 pesos, therefore our g of x will be represented by 100,000 over x plus 750. As per allocated amount for each child, the entries in the table will be the same as before plus an additional 750 pesos. The current world record in the 100-meter dash is held by Usain Bolt at 9.58 seconds, giving an average speed of about 10.44 meter per second. Assuming that sprint runners can run a distance of 10 meters in 1 second on average, a runner's speed may vary depending on how much time it would take them to cover 10 meters. Express the runner's speed v as a function of the travel time t in seconds. Solution. Speed is a measure of how fast an object is moving. That is, it is a measure of how much distance is covered over a time interval. For this example, we can express this relationship as the function t of t is equal to 10 all over t. Suppose that c of t, which is equal to 5t all over t squared plus 1 measured in milligrams per ml, represents the concentration of a drug in a patient's bloodstream t hours after the drug was administered. Construct a table of values for c of t for t equals 0, 1, 2, 5, and 10. Use a graphing software to generate a sketch of the graph of this function and interpret its results. Solution. Computing for the values of c of t for each specific t, we have the following results. To illustrate how these values were obtained, let's make a sample calculation. Let's say we compute for the value of c of t at t equals 5. So in our calculator, we construct our function for the value t equals 5. So we have 5 times 5 divided by the quantity 5 square, then plus 1. Obtaining 25 over 26, or in decimal, we have this as 0.96. The other entries in the table are obtained in a similar fashion. Next, we generate the graph of the function. The graph of the function c of t is generated using GeoGebra. It shows that the maximum drug concentration occurs around 1 hour after the drug was administered. For 1 hour, the graph suggests that the drug concentration decreases until it is almost 0.